Namaskar my dear friends. Let us talk about integration by parts. So this is very powerful method, and how to integrate like x cos x dx or log x sin a, log x dx, or so many like different kinds of functions are there where you have to apply integration by parts method. So generally it will be in the form of integration of u v dx, where u and v are two functions. Okay, so first of all we'll try to understand the theory part and then we'll see some questions. Okay, so what we'll do is, let us see, you already know, like let us say differentiation of uv, like multiplication terms. So what was that? You had u differentiation of v and then v differentiation of u, right? So similar to that we have integration term. So what will happen is integration of u v dx. Okay, let us consider that u and v both are functions of x. That's what we are considering in the beginning. So what will happen is we can do this by u integration of v dx minus integration of differentiation of u, like du by dx, into integration of v dx ka whole integration. So like that it will be. So what is the thing that I am telling you? I am telling you that this is, let us say, my first term, this is, let us say, my first function, and this is, let's say, my second function. Okay, so what is going to happen is first term into integration of second term, okay, minus the integral of differentiation of first term into integration of second term, and then whole integration. So this is how it will be called. One more thing that you have to take into account is ILATE rule. If it is possible, you just take care of this in your mind always. ILATE rule. So ILATE rule is nothing but it says, let us say you have a function x e to the power x dx, okay, or it is like x cos x dx. So something like these functions are there, and you don't know like which one I should take as u and which one I should take at v. Okay, so it is always a good understanding. I will tell you what is this rule, but first of all I will tell you how to decide that. Okay, so let us say you are going to do here differentiation, right? So if you are taking a function which is easily differentiable, okay, then it will be easy. So you can take up like x will be my first term, so that it will get vanished. So this is how your integration will reduce. Understood? Integration of like x will be little tough. It will become x square by 2. Instead of e to power x, it will become same. So we will take v as e to the power x and u as x. So this is how you should consider by yourself if you don't remember this rule, and if you remember, this is good. So ILATE rule tells that the preference of first function, or the preference of u function, okay, will be in this order. So first of all it will be inverse. I means inverse, like tan inverse, sin inverse, cos inverse. Then L means ILATE means L is logarithmic. Logarithmic function. Then A means algebraic function, and then we have trigonometric function, T for trigonometric, and last one we will be taking exponential. So this is the preferred term of taking as first function. Okay, first function. So hope you have a good understanding now how to consider the first function using my integration by parts. So now we will solve some questions and we'll try to understand how to solve them. So let us take some questions. Question is integration of x cos x dx. Okay, so what can we do? We can take x as u and cos x as v, like first function and second function. So we can solve it like integration first function into integration of second function cos x. I'll just write down formula here for first or one or two times. So integration of u v dx is going to be u integration of v dx minus integration of differentiation of u into integration of v dx whole integration. So this is the formula that we will use. Okay. Now let us try to see that. So what we are going to get is cos x dx minus integration of differentiation of x. So differentiation of x is, I'll write it down first here once or twice. Okay. So differentiation of x into integration of again cos x dx ka whole integration. Okay. Later on I will directly write this term like differentiation of x will become 1, so that it becomes bit easier to solve. Okay. No need to write down all these steps all the time. So what is the integration of cos x? It is sin x. So x sin x minus integration of, this will become 1 into integration of cos x is again sin x dx. Then it is going to come up as x sin x, and integration of sin x is minus cos x. So minus minus plus cos x plus some constant c. Okay. So this is the complete solution for integration of x cos x dx. Okay. Now let us take one more question. So question number 2 can be integration of log x dx. Okay. What shall we do? Let me take it down. Okay. So this can be written as, I can do one thing. I can do that as is equal to integration of log x into 1 dx. So I am just multiplying one extra. So our aim will be integration of u v dx is going to be equal to u integration of v dx minus integration of differentiation of u into integration of v dx whole integration. Okay. So using that formula we are going to write down our understanding here. So what will happen? My first function is log x. So I'll put it as log x integration of 1, because integration of log x is difficult. So integration of log x, I am not taking log x as second function. So I am taking log x as first function. Okay. Then integration of dx or 1 dx. Okay. Then minus integration of differentiation of what? Log x. So d by dx of log x into integration of again 1 and then whole integration. Okay. So this we are going to get it as log x into integration of dx is just x. Okay. Minus integration of, this is going to be how much? Differentiation of log x is 1 by x into integration of dx is just x and whole integration. So this we are going to get it as x log x minus, it got cancelled. So it is just dx, then it will become x plus some constant c. If you want, you can write it down as x into log x minus 1 plus c. So this is so simple question. Using integration by part, you are actually able to integrate it very easily. Let us take another question. So the question is integration of ax e to the power x dx. So what shall we do? Since differentiation of x is easy, so I'll take that as first function. So what I can do is x into integration of e to the power x dx minus integration of differentiation of first function, that is x, into integration of second function ka whole integration. Okay. So this is how we are going to do that. If you want, you can write down formula for your convenience. So like let's say integration of u v dx is going to be u integration of v dx minus integration of differentiation of u into integration of v dx ka whole integration. Okay. So that is the formula. So we will have x integration of e to the power x is again e to the power x. So x e to the power x minus integration of differentiation of x is 1 into integration of e to the power x is e to the power x dx. Then we are going to get it as, since you have already integrated one term, so you can always add one constant here, like let's say constant of integration c1 c2 something like that, and another integration you are doing, so one more constant will come. So both put together I am just putting at last one constant of integration, that doesn't matter. Okay, so you have to just understand that. So this will become x e to the power x minus e to the power x plus c, because integration of e to the power x is e to the power x only. Okay, let us take another question. So question is, so integration by part, you have to understand that it is very very important and it is very easy as well. So what we'll do is integration of x sine inverse x by square root of 1 minus x square dx. Okay, so does it look something like substitution principle or something like that? So we can first substitute and get it in like simplified form, and again we will try to do integration by parts. Okay, so this is the thing that we can do. So what we can do is we can utilize this formula uv. So integration by part was what? Integration of uv dx is u integration of v dx minus integration of differentiation of u into integration of v dx ka whole integration, right? Now let us say I am going to consider u as x by square root of 1 minus x square and v as sine inverse of x, because integration of, or what we will do is we will take up integration of this, and yeah, so or we will do the opposite way, we will take this one as u and the other one as v. Okay, so let us do that. Because like ILATE principle, so ILATE principle was telling that u as inverse, so inverse means sine inverse x, I will take it as u, and my v will be x by algebraic function, that is x by square root of 1 minus x square, right? So our aim would be to find out integration of x by root under x 1 minus x square. So first, why don't we do one thing, we will just find out integration of x by square root of 1 minus x square separately. Okay, so what we'll do, we can put it as, put 1 minus x square is equal to t. Then what will happen, we can take it as minus 2x dx is equal to dt. So from this our integration becomes here, integration of x dx can be written as minus dt by 2, so minus dt by 2 times square root of t, right? Because root under 1 minus x square can be written as square root of t. So this can be written as minus 1 by 2 is out, and this will become t to the power 1 minus 1 by 2 above, so it will become t to the power 1 by 2 divided by 1 by 2. So this will get cancelled, so it is going to be just minus root t, or it can be minus square root of 1 minus x square. So why we have done is, we can simply integrate this term to get this particular value, which is minus of square root of 1 minus x square. So now my integration is going to be first term, that is my sine inverse x into integration of second term. So integration of second term will be what, I will just write down the formula so that you can have a proper understanding. X by root under 1 minus x square dx, okay, minus integration of differentiation of sine inverse x into integration of first term, that is x by 1 minus x square square root of x square minus 1 square into whole integration, right? So this is how we are going to write down. Okay, so we are going to get first term as sine inverse x into integration of that was just now we found out minus of 1 minus x square minus integration of this whole thing. So differentiation of sine inverse is 1 by root under 1 minus x square into integration of this was minus of root under 1 minus x square and then dx, right? So integrating this, so we are going to cut these two, so we are going to left up with only minus 1. So we are going to get it as minus of sine inverse x into a square root of 1 minus x square into minus minus, it will become plus x plus some constant c. So this is very easy. So you are going to get x minus sine inverse of x, and so I will just rewrite this one as x minus square root of 1 minus x square sine inverse of x, because this is separate, okay, and plus c. So this is the complete solution that you are going to get. Okay, let us take another question. Question is question number, let us say, I think 5, right? So question is integration e to the power x sine x dx. So what shall we do? Since it is e to the power x sine x, so it is going to be pretty difficult, because neither sine x is going to end, neither cos x is going e to the power x is going to end. So differentiation, why do we do? So that one of the term gets vanished after some integration or differentiation. So what we'll do is we'll just try to consider this as, let us say I is equal to integration e to the power x sine x dx, and what is the formula do we have? Integration of u v dx is equal to u integration of v dx minus integration of differentiation of u into integration of v dx whole, right, and this whole integration. So can we do that I is equal to this one? So let us try to understand. First function we will consider as e to the power x. So what we are going to get? We are going to get e to the power x into integration of sine x, that is minus cos x, minus integration of differentiation of e to the power x, that is e to the power x into integration of sine x, that is going to be minus cos x, right, and dx. So this one we can write it as minus e to the power x cos x, and minus minus it is going to be plus integration e to the power x cos x dx. So this is, let us say, equation number 1. Now what do we do is, let us say this term is my I1. Now can we do one thing? My I1 can be written as I1 can be written as what? I1 can be written as integration of e to the power x cos x dx. So this one again can be found out as like this. Okay, so what do? We can do that e to the power x into integration of cos x is nothing but sin x minus integration of differentiation of e to the power x is e to the power x into integration of cos x is sin x, right, dx. Now you can see that e to the power x sin x is nothing but I. So I can do this is equal to I, right? So I1 is going to be e to the power x sin x minus I. So this is, let us say, equation number 2. Now by putting the value of equation number 2 in equation number 1, we can get the value of I. So what can we get? From equation number 1 we are going to get I is equal to e to the power minus e to the power x cos x, first term here minus e to the power x cos x plus I1. So I1 is nothing but this whole term. So this term I can write it down as plus e to the power x sin x minus I, and this I will come this side, so it will become 2i. So 2i is going to be equal to this, so I will be equal to, or 2i will be equal to e to the power x. I will take common, so it will become sin x minus cos x. So what will be my I? My I will become e to the power x into sin x minus cos x divided by 2 plus some constant c. Understood? So this is how we are going to get the value of integration of I, which is going to be e to the power x into sin x minus cos x by 2 plus some constant c. So this is very easy. Like, you consider one of the term as I, and we have also already considered another term as I1, and I1 we have evaluated in terms of again I, and this value we have put it back so that we get the complete solution. So alright guys, hope you have a complete understanding about this particular, like, integration by parts. And we have lot of questions in competitive examinations like GATE or CSIR or IES. So you can solve those questions also. We will be putting all those GATE questions in this particular series. So hope you have a complete understanding using this particular methods. Thank you.